First, we are going to calibrate the pH meter. After removing the probe bottle, rinse the probe with deionized water into a waste beaker. Then, put the probe into a beaker of the known pH 7 buffer solution. On the pH meter, tap Sensors, and then Calibrate, and then the box that will appear beside Calibrate. Tap Calibrate now, and enter pH 7 into the meter, and tap Keep. Rinse the probe off again and put into the known pH 4 buffer solution, and enter pH 4 into the meter, and tap Keep. You should test your calibration by again rinsing the probe and putting it back into the beaker of known pH 7 solution. Your pH meter should say 7. Now, we're going to test the pH of a hydrochloric acid solution. We made this dilution by putting 2 milliliters of 0.2 mol hydrochloric acid solution in a 25 milliliter volumetric flask. Then, we filled the flask the rest of the way to the line with water. Transfer the solution to a beaker so the pH probe can reach it. Rinse the probe off with deionized water and then put it in the beaker and wait for the pH meter to stop changing. When you're done using the pH meter, rinse the probe off again with deionized water and screw the bottle back on. Turn the pH meter off. These are our results testing the pH of serial dilutions of a strong acid, hydrochloric acid, and a weak acid, acetic acid. A strong acid dissociates completely in a solution, releasing all of its hydrogen atoms, or protons. A weak acid does not release all of its protons, causing the equilibrium to favor both the products and the reactants, whereas a strong acid dissociation reaction favors the products at equilibrium. A buffer solution could change that equilibrium. A buffer solution is one that stays at a relatively constant pH when acids or bases are added. It is a combination of a weak acid and its conjugate base, or a weak base and its conjugate acid. The weak acid or base can donate or accept protons from the added acid or base, keeping the overall solution at a constant pH.